Going live, you're live.
All right, so thank you so much for having me. My name is Ashley Walker, and I am a fourth year doctoral student at Howard University in the graduate program of Atmospheric Sciences. Welcome. Today, we're going to be talking about the cosmic outliers, Neptune and Uranus. I chose Neptune, Uranus, and Titan. There is some things with Neptune we'll be talking about a little bit, but more so specifically focusing on Uranus and Titan. And I chose these two because naturally, and as long as I can remember, Titan and Neptune have not, and Uranus have not gotten the amount of respect, as we must say, as we would like it to be. So I've chose this talk essentially to help everyone understand what's happening in the universe and in our known solar system, our very own backyard, and also the up and coming Dragonfly mission, which I'm a huge fan of since 2018 when I first heard about it as an undergrad. So let's get started. All right. And so, as we talk today and we think about what is happening within our solar system, what traditionally do you think about? And so we want to take some time to think about what do we think about in the solar system. When we think about it, right, we traditionally think of stars and planets. We also think about the sun, right? And these are some of the things that we think about. And also, I do have a cat. I have multiple cats, so you will be hearing them throughout this whole thing. They also like to make appearances as well. So, we have the moon within this. You know, things that are orbiting our sun, and that's additionally what we think about when it comes down to our solar system. And so, what are some questions that you may have when you think about alien atmospheres? I know sometimes when we think about alien atmospheres, we think about aliens itself, right? We think about aliens itself. We also think about we also think about Star Trek itself. We think about you know little green men invading us, finding other life. And those are some of the things that we think about when we think about alien atmospheres and some of the questions that we may have when we think about these atmospheres. And so, other questions may be what characteristics of alien atmosphere might indicate the presence of life. Now, when we think about the presence of life, we traditionally think about um, you know, other human forms or other forms that may not look like us or talk the way we do or have everything, the way that we do. And so, with this being said, you want to take in what do you think about when it comes to the presence of life as we may know it. Other questions include what role do atmospheric pressure and temperature play in shaping the environment of that planet? So, oftentimes people think like, okay, can we walk on it? Can we breathe? What is this particular alien atmosphere is composed of? These are certain things that we traditionally think about, because a lot of people are like, okay, I don't want to be on Earth anymore. I want to go live somewhere else, right? And so, and one of the celestial bodies that we're talking about today is actually closer in likeness with Earth than most places in our known solar system. So we'll be getting into that as well. Other things we can think about as well is what methods are used to determine and analyze these atmospheres. A lot of times, we think of people going in space, but we also think about like, okay, well, how do they detect these things, and how do we get that data back, and um, how do we interpret this data? And so, while we want to know more about, these atmospheres, but we also want to know, like, how can we um, understand a little bit more through these methods, right? And so some of these methods are actually used, a small fun fact, some of these methods are actually used back here on Earth. But why the one thing that I learned is that with some of the methods that were used, some of them have been known for used in space, and then we use them here for our very own like health environments. So some of the things that we may use may be for like MRIs and things of that nature, right? I learned that very early on in my career, and I was just like, wow, it's everyday tools that were used for space first that then comes back to help us understand our bodies more. And so this just the grand scheme of things of how everything is connected through the universe. And so all of these questions, again, I will be answering these questions throughout this entire series. And so I just want to make sure that, um, folks really, communicate how, what they want to know a little bit more about. So please let me know in the chat. So a brief history um, about Titan. So Saturn's moon Titan is the second largest moon. It's the largest moon of Saturn, and it was discovered by Christian Huygens in 1655. And so Voyager 1, I was not around when Voyager 1 was a flyby mission. However, this mission revealed the thick Earth-like atmosphere. And so, um, you know, when we learned about what happened with the Huygens mission, that was really, really helpful for us. And so the Cassini Voyager, but what Cassini-Huygens, which it was from 2004 to 2015, when we sent the probe there, and it crashed into Saturn, which was very, very sad. However, it was, learning a little bit more about the chemical composition of Titan, helped me understand a little bit more about hazy atmospheres and aerosols. And so we're going to get into a little bit about aerosol chemistry and microphysics. So we know like why we want to study and go to Titan, right? Because again, Titan is very Earth-like. And so this hazy prince, Titan, has, rivers, lakes, seas, sand, mountains, craters, all of these things that we would have here on Earth. Some of the things that we are very much intrigued by is this atmosphere, because we're like, okay, we thought that like, all right, Earth is very unique, as we all would agree. Earth is very unique. There, all the planets in the solar system and moons are very unique. However, what made Titan very much so very special is that it is exactly very much like early Earth. So we look at Titan as something of what the past may have been to give us clues about our very own Earth. And so this is why we want to study Titan, because we know the importance of understanding the hazy moon. And so Titan's upper atmosphere is Titan is very unique. And so one may think that when we look at the schematic, one may think like, what the hell is this? Okay, let's back up a bit. And I just want to start off by saying, which I should have said in the beginning when I started talking about Titan, is Titan is a jerk. Okay. And we know that Titan's a jerk because Titan won't let us peer into the clouds. Well, we know something about the clouds, but it is very hazy. So because it's very hazy, it won't allow us to see like what's actually, happening. So that's why it makes it more so of a jerk than what one may think, right? And so when we have, so it up in the upper atmosphere on the schematic, as you can see, um, we have the sun, which has, electron protons and has these energetic particles. And once it collides with the sunlight, it then gives off dissociation and ionization, which creating methane and nitrogen. And so then it gives us all these complex organic molecules, which are like, what the hell? Right. It gives us all these things, right, which we call hydrocarbons, which eventually produces these haze. And so that's why it's so hazy on Titan. Again, Titan is a jerk for this known reason because it's so hazy. And we're like, okay, we just want to, go by and look and see what's happening in that atmosphere. But unfortunately, because it's so hazy, we can't just peer off and see like, okay, well, maybe it has this, right? So when we did the Cassini-Huygens mission and we did the Voyager 1 mission, those allowed us to see what complex organic molecules that it's bringing to you all today. And so we are still we're still studying Titan, and we're still figuring out what's actually happening there. And so this is one of the coolest things that I thought. But Titan gets a little bit, cooler. Like I can go on and on about Titan because again, Titan is my first planetary atmosphere love. So it was the first moon, I'm sorry, that I worked with, and I just adore Titan. I really do. And so we'll get a little bit about my background in a bit. That's a little bit later. But for now, we want to focus on the actual moons. This particular moon and its atmosphere. Again, when we think about Titan actually is helped me study what we're thinking about when it comes to Uranus and Neptune, because they're also jerks because they're hazy as well, but not as hazy as Titan. And so its atmosphere and its surface, as you can see, this kind of looks similar to Earth, right? And so we have a surface here. And so while we have a surface here, we can see the methane and nitrogen clouds. And then we have the ethane haze layer. And so, but the one thing we want to notice is the altitude, right? And it's very similar to Earth, right? They have a troposphere just like we have a troposphere. They have a stratosphere just like we have a stratosphere. And so it's really important to note that Titan is very dense. It's a very dense atmosphere. And so because it's so dense, we would be, if we take two cardboard boxes and decide to use them as propellers to flap, we can fly, right? So you may want to think about, I always think about doing Mortal Kombat moves with someone on this surface. So it really is it's very dense, and there is pretty much no oxygen. So we are going to need masks if we ever get the chance to be there, right? Which, again, it's extremely Earth-like. And so one thing that we want to study a little bit more is we pretty much want to study if it does have any water. Now, we do know we have like liquid ice water around its cap, but we're not sure like how this is particularly um, if it's where it's producing, where is it coming from? And so that's why the mission Dragonfly is so important. And so Saturn, is one of the gas giants, and a gas giant queen, as I will call, Saturn. And so Saturn is very unique. It has, all these moons, and its special moon, as I just talked about, um, is really helping us understand what's happening in our solar system. Again, this is happening in our own backyards. And also a lot of times these moons and planets can help us understand exoplanetary atmospheres. And so exoplanets are planets that are outside of our solar system. So you want to think about how you're driving in your neighborhood, right? And then you're going to another neighborhood. That's exactly what exoplanets are. It's just going from one neighborhood to the next, right? We live in this solar neighborhood, right? In this community. And then outside of that, we have other solar systems in which those planets have formed and could be harboring what we may think about life. And so we want to think about, again, as we said before, some of our key questions. When we think about alien atmospheres, what are we thinking about, right? So now we're going to move on to Uranus. And so I love Uranus because of a few reasons, right? It rains diamonds. Diamonds are a girl's best friend. Hello. Um, we have, it's tilted, it's weird, it's different, it's extremely unique. And when my advisor first told me to work on Uranus, I was literally still stuck on Titan, and he was like, you can do Titan later. And I was just so upset. And then I became obsessed with Uranus because in my dissertation project, because I realized the uniqueness of this beautiful planet, right? And so I posed a question on X some years ago, and I asked everyone if you can have a planet that you could get rid of, which one was it? Now, I'm here to say that I would get rid of Mars, right? And Mercury. We kind of don't need those, right? However, my favorite planets and moons, I thought it was going one way and it went the other. And I say all of this to say that Uranus is very unique and don't get as much attention as her twin sister, Neptune. And so Uranus was discovered by William Herschel in 1781. And the very interesting fact I found out is that they didn't even think that it was a planet. They thought it was a comet. They thought it was like a comet or a meteorite. And I was just like, what? Like, wait, you didn't think, they did not think it was an actual planet. And that was very, very interesting. But as time progressed, Voyager 2, I still was not here on this earth at the time. In 1986, flew by Uranus and the Hubble, HST, Hubble Space Telescope, the 90s to 2000s. Now, I was here during that time. It provided us with, amazing images of, the ice girlies. And I think when I think of the ice girlies, I also often, think about Elsa, from Frozen. So I kind of think of those as we continue to study them, looking at its unique atmosphere. Because again, Uranus does not have a true surface. So it's very interesting to study something without a true surface. So this planet has blew my mind since I started studying it a few years ago. And so one thing that we know is that Uranus and Neptune the ice girlies are so far out of the solar system. They're, at the edge, but it's very mysterious, and it orbits 84 Earth years. So its composition is hydrogen, methane, helium. It's extremely cold. I don't think anyone could survive there. I would not want to. But it's one of those planets that you are like, it's very unique and we would love it from a distance. And I love my girlies. So it's something that I would not want to live on. However, and I know like rain diamonds, pressurized rain diamonds, how can I get them right? It's not worth it, but hey, it's amazing that we have this in our solar system. And so again, here's a schematic of um, of the composition. So as you can see, we have molecular hydrogen right here. We have metallic hydrogen, and this is for the gas giants all the way around, and then also in comparison to what we have in comparison to Earth. But we essentially have these. All of them have a rock core, and so something that an argument that we've been having is, should we call it an ice giant or a rock giant? And I'm just like, that makes no sense, but that's just me. And so that's kind of pretty much an argument that they're having within the space community, which people are still calling it ice giant. So I'm here for that. And so as you can see, traditionally when we study Jupiter and Saturn, we also study Uranus and Neptune because they're very much similar. And so we want to know more about their composition, how they're formed, um, what their atmosphere particularly look like, um, things that we have prematurely studied with Neptune and Uranus. And so here are some observations that have been taken with Voyager throughout time. So we have Voyager, we have HST, which is the Hubble, and we have the ground-based telescope observing of what it looks like. And as you can see, we can kind of see some of the clouds peering through, and how we can definitely see the rotation for Uranus right here. And they almost kind of look alike, right? They almost kind of look alike. They look like twins, right? And so with these clouds peering through, we want to know a little bit more about their clouds. I particularly am studying their clouds right now. So it's very fascinating to connect it back to Earth, but also understanding how this helps us with climate, with planetary climate. And so speaking of planetary climate, here's a schematic of what actually happens on Neptune and Uranus. So remember earlier we talked about the troposphere and the stratosphere. And so Neptune and Uranus both have a troposphere and a stratosphere. And in this schematic, we have the same similar haze that Titan has, Neptune and Uranus also have. So they have a photochemical haze. So it's coming from the sunlight. So from when that sunlight hits, it creates these energetic particles that come on down and create this haze, this thick haze. But the difference is about right here at one bar. It begins to create concentrated ice and snow, which then is coming down and sediment onto the surface. So it begins condensing, which is now H2S, which is hydrogen sulfide. So so I know that most folks mention rotten eggs in Uranus and Neptune. So pretty much, yeah, I study fart clouds. Okay. All right. So we got that out the way. So it smells like fart, essentially, which is a funny way to think about it. So again, it brings this snow and ice down, but it also is creating these ring diamonds, which comes down which redeposits down to the quote unquote surface, but then it spouts it back up, which is very cool. And I was just like, okay, all right, we got to figure out why is that, right? So we're still figuring that out. However, this is essentially what is happening with the clouds on Neptune and Uranus. And it's also very intriguing to a lot of my peers. And so while we're talking about our ice girly, Uranus, so here's a recent image that was shared widely throughout the media from the Hubble image, which we have the one from the Hubble, and then we have the one for JWST, which it looks like a very beautiful crystal ball that is like shimmering, right? And it displays the brightness of the cap right here, which you can see like the clouds here, and then there's clouds also over this way as well. So we want to know a little bit more about what's happening at its quote unquote North Pole, right? And we want to know what's happening overall on the planet. We know that it's very windy on Uranus, and Neptune is extremely windy, but we also want to know, like, how does that affect everything else that is happening on on that particular planet, so it can help us navigate with exoplanetary atmospheres in our exoplanetary systems. And so, yes, Neptune is a cosplayer. I did not want to break the news to folks, but Neptune is definitely a cosplayer. When I first found out, I was just like, I just knew. So and I think this can help us talk about why Neptune and Uranus have this unique color. It's mainly because of the methane in the upper atmosphere, which causes it to get that uniqueness about it, right? But when the folks over at Oxford, Pat Irwin, went and they re-imaged and reprocessed these photos. This is the actual color, and they're twins. Like, they're twins. So Neptune is a cosplayer. I still love Neptune, but it's a cosplayer, and we now know, that this right here is the actual color of Neptune. So what have you learned about planetary atmospheres today, right? When we think about alien atmospheres, are we thinking that, okay, when we think about habitability, does that include more plant life? Does that include water? Does that include everything else, right? Do we think about what happens when it rains on Titan, which rains methane and ethane? I mean, which rains methane and ethane, and it has methane and ethane lakes and rivers and seas and mountains and everything else, right? When we think about planetary habitability, did we think about it snowing on Uranus with methane and becoming H2S clouds, right? Bark clouds, right? When we think about habitability, what other things have we not thought about when it comes to planetary habitability, and what we intend on thinking about when it comes to future space exploration? I think that when we think about future space exploration, um, we don't often we think about again, finding aliens. That's amazing. However, we forget about planetary climate. And so planet, just like climate here on Earth, is very, very important. It's also important on other exoplanetary atmospheres and solar system atmospheres. And so the future of space exploration is the Dragonfly mission, which is supposed to go out in 2027, if I'm not mistaken. Let's see how that goes. But the Dragonfly mission is a rotocopter that will go and study some of the geological influences, some of the geological things that's happening on Titan, but it also will study some of the upper atmosphere as well. So it'll give us a good view and a better understanding of what we missed when with Voyager and Cassini, um, and other type of data that we may not have thought about. And the Uranus orbiter and probe flagship mission is still in potential mission space. From what I know folks really want this mission to go. I want this mission to go. I would like to be the PI, but I know that's not possible because I'm too junior. However, I would love to see how this mission um, comes about in the future, because you know as we think about a lot of amazing folks, science communicators, and folks that have really honed in into science and what what we want to see out of these things. I think that it's really important to understand what is happening, again, with how all of this is connected, from from what you know what's happening with the Europa Clipper, what's happening with Dragonfly, what's happening with Mars, how all of this is connected back here to home. And so, how can this help us with space exploration? And so here is my organization, Black and Astro. So I'll give you a little Black and Astro history for Black History Month. And then we will have an open floor discussion. So Black and Astro was founded in 2020. I am the president and founder of Black and Astro, and we created a communal support for Black folks within the space community around the world, not just in the US. Here are myself and some amazing astronomers. This guy right here is all over TikTok. I just was actually texting him before I hopped on. His name is Dakota Tyler, aka DT Starkid. You can follow some of his work all through social media. And then we have some amazing folks like Keyshawn Ivory, Caprice Phillips, my vice president, and my cousin, who is also the COO, Robert Washington. And so those are just some of the people within the community and on the board that have been helping to provide support. So we're going to dive a little bit into it. So if you haven't heard of Black Space Week, Black Space Week it was initially called Black and Astro Week. Black Space Week is a week every year in June, during the week of Juneteenth, where we celebrate us around the world, and you actually can get some cool science out of it. So this year we're focused on the humanities. So folks that like to hear more about, literature, journalism, social sciences, this year will be your year. But we're still doing the science. Please know we're still doing the science here. And so we've had a lot of amazing things over the last 5 years to celebrate about. One, seeing that we collaborated with the White House National Space Council for the past 2 Black Space Weeks. So in 2023 and 2024. 2023 was our inaugural in-person event. So we had a chance to have some amazing folks appear. There was a video, if you go to Kamala Harris's, former Vice President Kamala Harris's page on Twitter or any of the socials, you'll see a video with her and Ed Dwight celebrating Black Space Week. Which I saw that and I was like in the audience crying because I'm sensitive, and they were like, "Oh my God, please don't tell us this lady, Kamala's here because Ashley's going to lose it and this is going to be bad. No, she didn't come. However, we did get a letter from her. And so this is me and some of the team and some folks that was helping us. But there are some familiar faces here. This is Dr. Cyan Proctor, who is the first Black woman to be pilot in outer space for a spacecraft. And this is, I think this is one of, a Trekkie, if I'm not mistaken. Celia Rose Gooding, who also appeared during the first inaugural Black Space Week. And yes, that's me. I'm very little. Um, but, we've had some amazing folks to help us celebrate what we're doing and the work, the causes that we do, right? And so we're also collaborating, we're collaborating with the Neuroverse Initiative, which is why I'm here, by the way. And so here's us this last month at the American Astronomical Society. We're just waiting to meet one of the U.S. congressmen. So we just decided to take a picture while we were there. So we had a lot of fun times presenting our science. And my vice president gave her dissertation talk, which was very much amazing. And our events coordinator, Keyshawn, also gave a talk, and Rob did as well. I just did a lot of running around, okay? And I did Astronomy on Tap. So if you haven't heard of Astronomy on Tap is where you can get beer and watch scientists talk crap about their science. So check it out. It is generally in, I think in like almost all states, but it is around the world for sure. And so while we're talking about space exploration, this was the past, present, and future of human space flight. And so here's Ed Dwight, as I talked about earlier with the video with Kamala Harris. This is literally after the video. And so here's him talking to some of the astronauts, Victor Glover. You have Victor Glover here. You have Yvonne Cagle here. So you have a lot of amazing folks that were present during that time. This is in 2000. This was last year, 2024. But here was Naya, our aerospace engineering chair for Black and Astro, meeting her hero, her shero, Dr. Mae Jamison. So who also is a Trekkie. So we had some amazing folks. Again, we had some amazing folks, and we actually collaborated with Paramount to give some giveaways away, which were amazing throughout Black Space Week events. So we're really, really excited to bring this to life and to bring us all together. And so you can find us on our social medias. We're everywhere, but here's our link right here. And you can follow the Neuroverse Initiative, which again, you will see Jess and Liv later on. But I am really, really excited to be here. Thank you all so much. And I will be taking questions at any bit. Okay. And so something that I do want to share outside of like Black and Astro and the Neuroverse is that please let me know. You can find me on all the socials. My name will Dragonfly land on Uranus. No, it won't land on Uranus. It will land on Titan though. It will land on Titan. And so we will have a we will eventually, depending on how everything goes with everything that is happening now, we hope to have the Uranus orbiter and probe flagship mission be developed, and it has to go through these series where it's like it's kind of like you want to think of it like Miss America, right? Where you have the beauty pageant and they're like, ooh la la, and this is a 10, and this is yada, 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 right? Well, we have our own version of that for planetary science, right? For missions. So Dragonfly went through that process and it was selected, which was wonderful. However, now the Uranus orbiter flagship mission has to go through that as well. So it has to go through the ooh la la phase where it competes against other missions to get the top pick. And so we have this thing called the decadal survey, where the survey said that like where the decadal survey said that Uranus is the top mission. And so because it's the top mission, um, it would, I'm pretty sure it would get picked. I'm almost confident it would get picked. But unfortunately, right now, seeing how everything is going, we just want to make sure we get that mission off the ground. Just like we did with JWST. There also is another proposed mission called Habitable Worlds Observatory, which is amazing because we're studying everything. It is like the super Hubble. So if you all remember, I talked about the Hubble Space Telescope just a little bit, but it's the super Hubble where it will look at the solar system, it'll look at comets, it will look at how planets are formed, galaxies, blazar, anything in the solar system, it will basically look at particularly and help us distinguish what is, happening. And so supporting Black and Astro, um, you can all follow us on our socials. We have donation links on there as I had up earlier. And then also, we're prepping for Black Space Week this year, which we're extremely excited about. And whenever you hear of events in our town, just spread the word to folks because we have our events in DC. I think this year we're having it in DC, but I know next year for sure we're going to have it here in my hometown of Chicago. So you can also like come share things with us. So some planets are different than others. Again, like with Titan, like as we talked about with when it comes like so the question is, what is gravity like on some of these planets? So some is different than others, right? So for example, on Titan, because it's such a dense atmosphere, you bounce and like you can scissor kick someone in the air, right? Like Mortal Kombat style or Tekken, right? But also you have some that, like was a Jupiter that gives it a gravitational push when we have space missions that can help us get to where we got to go. And this is why, like timing, you may hear scientists freak out about like why timing is so important, because that same gravity, that same gravitational push can help us get to other planets. And so it's once again, it's very, very important for us to understand like um, how we want to get there and how does all of this work together, right? How did what we understood on the earth like 50 years ago in comparison to now is now being applied to planetary atmospheres, right? So studying planetary climate is amazing. And Again, some of the gravity can be a little bit different bearing on the planet. So it did, or moon. In this case, a moon, because because that was something too that I thought about. Like, is should Titan be classified as a moon? So. So the question is, when Titan lands, I'm sorry, when Dragonfly lands on Titan, will it send us pictures of water back on the moon? So it will essentially send back data, because it has certain laboratory components in the rotocopter that will be able to send back data to Earth, and so those scientists will then work on them. Will reproduce that in the lab to see, okay, if we know it's this, then how can we replicate it, right? So that way we will be able to know what's actually happening, with Titan. And I know that when I first started working on my project, it was one potential mission that was like for water in particularly, and I knew my advisor at the time, she wanted me and one of the other girls to work on it, but unfortunately didn't get picked. It was again, it was a part of the beauty pageant, right? It was the beauty pageant of missions, and it did not work, unfortunately, but that doesn't mean we can't still try. So um essentially we should be able to see what uh you know what's happening. Another question is, will you be at the convention in Chicago again? Absolutely. I would love to come back. I will definitely be, I'm here, I'm local. So I definitely would be there, especially if Jessica will have me, which I'm pretty sure Jessica's watching and is going to text me. So that is my time for today. Thank you all so much for having me. It's snowing here in Chicago, so like Valentine's it's not canceled, but it's canceled. But it's snowing here in Chicago. But wherever you are, I hope it's sunny. I hope it's beautiful. I hope it's safe. Um, Again, thank you all for having me. Thank you for supporting the Neuroverse Initiative and Black and Astro. Thank you all so very much.